Hello, viewers. In integral calculus, there are few important formulas. Today, we will discuss one of them and apply the formula to evaluate some definite integral. The formula is integration from 0 to af of x dx is equal to integration from 0 to af of a minus x dx. To prove this formula, we will perform a change of variables. Let x be equal to a minus t, where t is another variable, which implies that dx is equal to negative dt. Also, we have observed that when x is equal to 0, we have t equal to a, and when x is equal to a, we have t equal to 0. Therefore, the integral can be rewritten as integration from 0 to af of x dx is equal to negative integration from a to 0 f of a minus t dt. By reversing the limits of integration, we get integration from 0 to af of x dx is equal to integration from 0 to af of a minus t dt. As we know that integration from 0 to af of x dx equal minus integration from a to 0 f of x dx, since t is a dummy variable of integration, we can replace it with x, giving us integration from 0 to af of x dx is equal to integration from 0 to af of a minus x dx. Thus, we have proved this formula. Now, let's solve some specific problems by applying this formula. The question is to evaluate integration from 0 to pi by 2 square root of sine x whole divided by the square root of sine x plus the square root of cos x dx. To solve this, let us denote I is equal to integration from 0 to pi by 2 of the square root of sine x whole divided by the square root of sine x plus the square root of cos x dx, and label this expression as equation 1. Here we apply the formula integration from 0 to af of x dx is equal to integration from 0 to af of a minus x dx, where a is pi by 2, thus the above expression is equal to integration from 0 to pi by 2 of the square root of sine pi by 2 minus x whole divided by the square root of sine pi by 2 minus x plus the square root of cos pi by 2 minus x dx. Now we know that sine pi by 2 minus x equal to cos x, and cos pi by 2 minus x equal to sine x, hence can rewrite the integral as integration from 0 to pi by 2 of the square root of cos x whole divided by the square root of cos x plus the square root of sine x dx. Label this expression as equation 2. Adding the original integral to this new form, that is equation number 1 plus equation number 2, we get 2 times I is equal to integration from 0 to pi by 2, the square root of sine x plus square root of cos x whole divided the square root of sine x plus the square root of cos x. As the numerator and denominator are same, they will be cut to each other, and we have the expression as integration from 0 to pi by 2 dx, which is equal to pi divided by 2. Thus we find that I is equal to pi divided by 4, which is our required result. Let's consider one more problem. On here we need to evaluate the integral of log of 1 plus the tan theta over the interval from 0 to pi by 4. To solve this, let's denote the integral as I, using a formula discussed earlier, that is integration from 0 to af of x is equal to the integration from 0 to af of a minus x. In our case, a is equal to pi by 4 and x is theta. This allows us to rewrite the integral as the integration from 0 to pi by 4 of the log of 1 plus the tan of pi by 4 minus theta. For the second expression of the inside log function, that tan of pi by 4 minus theta, we will apply the tan a minus b trigonometric formula, that is tan a minus tan b whole divided by 1 plus tan a tan b. Here capital A is pi by 4 and capital B is small theta. Thus tan pi by 4 minus theta is equal to 1 minus tan a whole divided by 1 plus tan theta. As we know, tan pi by 4 is 1. Thus our integral is reduced to 1 plus 1 minus tan theta whole divided by 1 plus tan theta over the integral from 0 to pi by 4. Simplifying this expression inside the log gives the result 2 by 1 plus the tan theta. Next, we use the logarithmic identity log of a divided by b is equal to the log of a minus the log of b. This allows us to rewrite the integral as the integral from 0 to pi by 4 of the log of 2 minus the log of 1 plus the tan theta. That is, log of two integrals from 0 to pi by 4 minus integral matches the original expression for I. Rearranging the terms gives us twice the value of 2i is equal to pi by 4 times the log of 2. Therefore, the value of I is pi by 8 times the logarithm of 2. Let us solve one more problem, finding the integral from 0 to 1 of the log of 1 plus x divided by 1 plus x squared. In this case, let's set x as tan theta. This means we're rewriting x in terms of the tangent function. Thus, we have dx is equal to sec squared theta d theta. On the other hand, when x is 0, we have theta equal to tan inverse 0, that is theta equal to 0. And when x is 1, we have theta equal to tan inverse 1, that is theta equal to pi by 4. Now the integral is reduced to integration from 0 to pi by 4 log of 1 plus tan theta divided by 1 plus tan squared theta sec squared theta d theta. Now we know that 1 plus tan theta equal to c square theta. Thus we have integration from 0 to pi by 4 log of 1 plus tan theta d theta. Now this problem is same as previous, and the corresponding value is pi by 8 times the logarithm of 2. Thank you for watching. Have a nice day.